Yeah, good morning, all of you. My screen is visible.
Yes, sir.
Okay, okay, we'll see the working of PSO for sphere function. Like that, we may have the different test functions. Even we can solve this using our power system problem cases also. Now, to understand basic PSO, we are going with one test function. That function may be anything. You want to change this function also, you can change. Because just for understanding, I'm using as a sphere function for all the problems. So like whether it is a GA or PSO or DE or whatever may be the problem, I will take it as a common problem so that we can easily understand the difference and all. Now, in this case, the sphere function, the limits also mention 0 to 10, meaning is x limits and y limits. You can, or you can say that, not x limit, y limit. It is a minimum and maximum limits of the particular x. So, once if you consider as a four variables, x1 minimum is 0 and maximum is 10, like that. So while we are doing the problem, the answers must be within the limits 0 to 10 limits. Similarly, x2 0 to 10 only, because I is given 1 to 4 and xi is 0 to 10, so that we can easily get the variations. Now our decision variables are x1 to x4. Our intention to find the best values x1 to x4 such that our function will be minimum. That is only the problem. As per the algorithm, we have seen in the last class, and that is mentioned as a step 1, step 2 and all. The same procedure we are going to apply here. Now, as per the GA also, we need as a population. So for all, what you call it as optimization algorithms, we need to start with the population. So here you are taking population size is 5. And in the previous, in the upcoming equations, let it be as a velocity equation, and then position updation and all. So velocity equation, as you know, that W into VI plus something into P X minus P, C global best, and similarly P what you call it, a personal best, G best, and then P best minus this. So all these formula we have for the velocity updation. Once if we know the velocity updation, we can easily find the position updation in the initial position plus velocity position updation. For all these, whatever the constant variables are there, uh, that variables we need to change. Just a minute. So now for that reason, these values we need initial values. That's what I'm considering. W value. Just a minute. Mm, so this W is zero point 0.7 we taken randomly, and C1, C2 values. The later point of time, this C1 and C2 also we are going to calculate. using the formula by using modified Pearson problem. Mm, in that case, see, we need to fix this for the basic case and total number of iterations I have taken as a 10. But in the real problem, while you are doing through code, this NP, you make it as a something 100 or 50, and the number of iterations, you can take it as 100 also. So, in that manner, we will go for the programming part. Now, this is the first step. What we did is we are simply calculating the, when what you call it as we are the parameters, that is population size, inertia weight, W is inertia weight, and acceleration coefficients, and maximum iteration. So these are all the uh, parameters we need to set up. And step 2, generate a random position within the domain. So evaluate the fitness. So now, as I mentioned, randomly for this step also is similar to GA only. We need to select a random population. So how many population are taken as a 5 population? You must consider all 5 population, but these values, why all 4 columns we have, we can check it. Population size is 5, so 5 rows, and 4 columns we have taken. The 4 columns because of these variables. The number of variables are 4. Suppose some other problem, number of variables only 2, then we can take it as a 2 columns only. That means 5 rows, 2 columns. The rows represent the population size, and columns represent the control variables is given in the problem or a function. Now here we got these values using the code we need to generate randomly, or for while you are doing manual calculation, we can consider random numbers. So now within the limit, now we can check this. This first column is x1, second column x2, third x3, and x4. If you have noticed any of the column, these values is always 0 to 10 only, because x1 or x2 or x3, x4, any value, the limits are mentioned 0 to 10. That's why while you are generating the random values, always within the limits. So that limits will be, we can say that 0 to 10. And now you substitute this value in a function, we will get it as a 80. How we can get this? 4 square plus 0 square plus 0 square plus 8 square. This will be as a 80. Similarly, 3 square plus 1 square plus 9 square plus 7 square, that will be as a 140. That you can calculate all function values from step 2. So what I did is simply generate the random population and then calculate the function value. Now we'll go for step 3. What we need to do is to calculate this, we require velocity, initial velocity also. For that reason, randomly I generated one more vector of the initial velocity. Let v vector is a velocity vector. Generate the random velocities within the domain of variable. Again, variable x1, x2, x3, x4. For these variables, the limits are 0 to 10 only, and we have to generate the vector. In this vector, we can notice the there is a mm, random generation, all the values within the limits 0 to 10 only. Now, so far, what I did is just population vector. You substitute this population vector, we'll get it as a function vector, and randomly we need to generate one more row matrix with consisting of 5 rows because 5 populations and 4 columns that will be as a variable, x variables that we can get it as a uh, velocity vector. So now we can see determine the personal and global best. So next step is we need to identify what is the personal best value and global best value. How can I find that? Because it is a minimization problem. We need to calculate the minimum function value. That's why if it is a minimum value, then I can treat it as a individual individual value is a personal best, overall best is a global best. Now, among all this, we can see this solution, which is the minimum, 35 is the minimum. So that's the reason that corresponding x1, x2 values because this population p best personal best individual variables x1 x2 x3 x4 are the what you call it as a personal best values only and among that these are all first iteration only we started initial. That's why whatever variable values we are getting, that is the our first attempt of exam. Let us assume that whatever rank we are getting, that is your individual best. But who is the topper in a class? Who is having as a best rank? Best rank means minimum rank. Let us assume, and that he will be the topper. So 35 is the minimum rank and corresponding subjects rank will be like this. Now I can consider x value is x1 is 0, x2 is 3, x3 is 1, x4 is 5. Then that will be as a uh, variable, control variable best values and function value is a f best. Now what we know is g best, global best. So global best are these values. So therefore 0, 3, 1, 5 are the global best and F global best, FG best. This is the variable and this value is equal to 35. So all these things we can able to get it as a P best and G best. Now first solution that we call it as a generation. Now we can see how first solution is as on now we know the individual personal best and global best, function global best and variable global best. X1, X2, X3, X4 control variable best solution is known and another one we can say that mm, G best also I known that. So G best is a global best. Function global best is 35. Now what we need to do is next step we need to perform the new solution. So how we can generate a two set of random vectors. That means first generation each population totally 5 population each population we need to generate new solution. You can see. And the modification you have to generate for this and so on. So now the formula is as per our formula velocity and position updation. New solution means for first agent or first person you want to move one direction because his personal best or his rank is known to be known and other person's rank also known. What he will try, this agent is trying to get the best rank when compared to the other persons. So that is the reason he will move or object identification or whatever the object you want to go in that direction. So whatever present position, he want to move another position with some velocity. So the velocity formula is this one. W into Vi plus C1 R1 into P best minus Xi plus C2 R2 into G best minus Xi. That is the formula. For that, what are the values is required that you can put it first. Suppose V1, I want to calculate the V1. How can I calculate using the formula? W is already in the step 1, which is 0.7 into and WI, VI. So VI is the first velocity. For first person I am doing first person velocity is a V. This is V vector, no? V vector VI. V1, V2, V3, all these things will be available here. So therefore, 9618. And we can make it as a here, 9618. So V1 is over. Then plus C1 into R1. C1, C2 already fixed in the previous static set. That's where they remain at 1.5. This is the C1 into R1. R is a random vector. We need to generate R value from 0 to 1. For that, any random value we can generate. Suppose 0.2 or 0.2 or 0.6. How many based on the control variable? Let's do as a 0.1. So this is the R1. So C1 is known, R1 is known. Multiply with what? P best of the particular row. So in this case, P best is a personal best, whatever the first initial value only, no? That's why these are the personal best. So P best of the first candidate. This will be 4008. We can multiply here 4008 minus what is the xi? Xi also for the first case only, no? That is also same. For the next iteration, personal best and that particular solution may be different, but we are starting the first iteration. Whatever the personal best is same as the is solution. So therefore that is minus and plus C2 R2. C2 also 1.5. R2 randomly generate four numbers between 0 to 1 and global best is known. What is the global best? This value, this row is our global best. 0, 3, 1, 5 is our global best and minus xi. So now we can see global best is maybe third guy or fourth guy, but his best solution is 9, 6, something. Yeah, first person, no, 0, 4008, this one. So now we can substitute all the data. We can see I'm V1, this one. W is zero point 0.9 and then V1 for the vector V1 is mentioned first row and that I placed and C1 value that is 1.5 R1 randomly you have to generate this random number may be anything and multiplied by P best that is 4008 minus the particular person X1 means first row you can then plus made it as a plus and then C2 1.5 and R2 again we have to generate random numbers from 0 to 1 only in the four control variables, four values and this also over. Then the best solution VG G best. The third guy is having as a G best. That's why we are getting as a that value. And now we can see G best value is the third guy 0315 minus xi is a first row. So xi is the first. Suppose second time we are doing for second person, we'll make it as a V2. That is W into V2 plus C1 R1 P best of 2 minus X2. That second row data will take it. And if you do that, what we are getting is V1 value, velocity. So what we need to do is to generate as a first solution, we require velocity and position. So in that case, velocity is calculated this one. Velocity is this one. Yeah, this is the velocity. And how position will get? So earlier position is, we can see in this case, first person position is 4008. His position is that. And now x1 new position is equal to old position plus velocity. That is only the formula. So therefore old position is 4008 and plus velocity we already calculated 1.5 because V1 velocity while we are calculating x1 new and we got the new position. Like that, we need to perform for all the populations. Now, what is here intention is whether new position is best or not. While you are writing second time exam, there is no rule such that second time always will perform the best. Not like that. So sometimes first performance may be good. Second, after writing the next time exam or something, you may not be reach the same position. Sometimes it will deteriorate also. Sometimes it may be increasing your performance. So it may be anything may happen. So now what we can do is we calculated the new position for the X1 or first person or first agent. Now, whether these values are correct or not. So, whatever we got the values, we have to check that boundary of the solution. Now, the new position is this one. Let us assume that old position is what? Our old marks or rank or something. This is the old one. All these variable, this is x1, x2, x3, x4. These are within the limits. What are the limits? 0 to 10. So all these are within the limits. Therefore, your solution is a valid solution in that new one, the old one. This is 4G. Similarly, after performing the next step, whether you are moving in the right direction or within the boundary or out of boundary, you need to check. So all these values you can see. This one is 5.5, 5.1, 1.75, 11.8. So now we can notice one observation here. The new solution, the fourth one, it is a out of boundary. What is your limit? Maximum limit is 10. Minimum limit is 0. So maximum limit is 10. So 0 to 10, that is the reason I can able to change this value. So because if the exam is conducting 20 marks, let us say. Now if you get uh, 25 marks, what it means, it is not a valid solution. So you may be added some choice questions answers marks also. In that case, maximum is possible only 20 marks exam means even if you get 25 also you have to round it as a 20 only, because if you may add some additional access choice questions answers and all. So or sometimes your marks is negative. Suppose -3, -5 something due to negative marks are and all, whatever may be reason. In that case also, if limits are 0 to 10, if it is violating upper limit, set to the upper value. If it is violating lower limit, set to the lower value. That is the checking after generating as a new solution. In that case, once the new solution is generated, You need to verify the values within the boundaries or not. So if it is within the boundaries, then it will be as a valid. Otherwise, we need to check the what you call it as boundaries. So we have to set back to the boundaries. So now what I will do is I'm checking each and every one. For that reason, I'm giving one diagram here. If it is x new is within the boundary, so new value is something like this. It is a lower limit. So no need to change. If it is within the boundaries, no need to modify anything. But suppose your solution is here. The limits is here to here only, but your solution is beyond the upper limit, then you have to make it to upper limit only. And that's what you can see. Shift x new to the upper bound. Why we need to shift to the upper bound? It is violated the upper bound side. So upper maximum is this. So now we need to set back to the maximum value. Suppose it is 11.5 something. Now maximum is 10. You have to keep it into 10 only. Similarly, another case you can see lower side. Lower side is 0 here and it is getting as a minus value. Suppose something like this, violating the lower bound. In that case, x new shift x new to the lower bound. So whether we need to go for upper bound or a lower bound, we can able to perform that. So then we can see that same thing we are dating the limits. So what is the limits? 11.8 is violating. So what you have to set as per the previous explanation, I need to set to the 10 value. Now we have first solution position, velocity and then position. Once these two are happened, now what you can do, you evaluate the function. How can, because this is x1 value, x2 value, x3 and x4 and put it into function. F min that is equal to 5.5 square plus 5.1 square plus 1.75 square plus 10 square. So in that case, we'll get it as a new solution will be the function value is 159. Now the question will arise whether I want to take it as a new position is a right one or a wrong one. How can I judge that? Because our second time exam results rank is 159, let us assume that. But first time exam results, uh, this is first person I am calculating so far. This really is 80 and after his rank will be 150. That means what is not going in the right direction. So we can see that population updation, if we do this one, no update in the previous one. Why we going to update? Whenever if the second time result is better, then only we have to update. Otherwise, if that is worse, we cannot take into account. That results we can simply discard. So that's what we can see here. The earlier new solution is not better because it is getting 159.32. So we will not consider new solution. We'll consider only the best solution. P best will not update now. Why? Because first time P best is the good when compared to the second one. Now how to update the global best? Because earlier global best is 35, but now it is person 159, therefore we cannot update upper also. Upper is also the previous guy only the upper because this first performer is not performed well, his rank is less than the previous one, greater than previous one, and that is the reason the P best and G best updation will not happen for the first candidate. So that's what I written. And no update for P. First guy for G best. Suppose you can check it. If any reason this value may be 1001, let us assume that. Then what is your function value? 2. And now what will happen? What I have to do is here this sentence will slightly modify and in no you can remove update the P base. So what is the update P base? Earlier 4001. Now we can update to 1001. This instead of 80, this will become as a 2. And global best also going to update. So why? Because this is value only 2 rather than 35, which is minimum is the best because here function is a minimization problem. That's the reason now update the gbest also. What we can update here instead of the previous gbest, you can see here previously 0315 is the best and function value is 35. So now what I will do is I will update the gbest value also. What is gbest now? This is 1, 0, 0, 1. The solution is 2. Now gbest updated and gbest updated if the function value is better than previous iteration or previous random solution. But in this case, it will not happen because the first person rank or something, his function value is 159. Earlier it is only 80. That's why P best will not update, G best will not update. Now we can do second solution. So again you have to repeat for second person because our population vector and velocity vector consisting of 5 rows and 4 columns. 5 rows, each row is a one solution. We are using that variables x1 to x4. We are finding the function value. That's why we generated randomly 5 populations. In that second population, how we are going to generate? Now take it as a population vector. In that first one is over, then you take it only the second one here. So after getting the second one, what we can do, generate the two set of random vectors r1 and r2 because these are all required here. R1 is required, R2 is required, then C1 C2 is already fixed, W is fixed. Here Vi is nothing but a V2. Now that will get it from the second row because total 5 is there. No, second row you can you need to take it. And P best and G best earlier and this case not updated so far. Same data you can use it. If it is coming from here, P best and G best. If it is not updated perfectly, then you can go for if the best solution is arrived, then automatically here it will update. That updated value, you have to use it there. But in this case, this is not updated. So earlier P best and G best will be the same. So now what you can do is, again we have to determine the velocity using the same formula and new velocity you can check it. Minus values are there. So what you have to do? When the either it is lower best or upper best, then you can see the new velocity and new position. I will get the new position, present position plus velocity. We can write it as a new solution. So once new solution we arrived, then we have to go for as a function value. And then again we compare the previous solution with this PSO. So like that you can see second solution update, whether update is required or not. We can observe here the x2 values are this one. Now can see x2 values are within the limits only. 3.32, 3.2, 1.5, 6.4. So all within the 0 to 10 only. So no need to modify any of the variable. Now after that you can find the function. So once there is no modification, we'll go for as a function. So f is equal to means second guy f2 if you want 3.35 square plus 3.2 square plus 1.5 square plus 6.4 square. Now, what is the solution for this when compared to the previous one? So, previous 140 is there. Now, you calculate this. If it is less than 140, now we can select second guy is a best solution like that. Now, all the limits are within. Now directly we calculated the function. Now the function is 64. Earlier it is a 140. Now what is the updation? Personal best is improved. Personal best is 64.67. Earlier it was 140. So his personal best is replaced with 140 by this one. Now 64.67. So that is what the update the personal best. Then whether global best is updated, global best is still 35 is a minimum. So global best will not update. So no global best updation. So that is what we can make it here. Global best will be remains same. So now once the global best is not updated, then we can proceed. This is the solution for the next one. So now what you have to do for third person, we need to do the solution calculation. Again, only these two calculation. One is a velocity for third person and position for third person. So once we are repeating this procedure, again you can see this is within the limit. So directly you can go for as a function value 4.9 square plus 5.8 square plus 1.7 square plus 7.8 square. So like that, what is observation is here. Now this guy is rating second time. Earlier he is a topper because his value is I think only 35. You can see 35, but now his value or rank is a 121.38. Then what you have to do will not update his personal best because earlier personal best is 35 only. Will keep remains the personal best of third guy and the global best of the system is going to modify. Earlier, this guy is a 35, he is become as a global best. Now, that value is less than that. Now we can make it as a is will not consider as a personal best variation. Now will remain previous one will be the personal best and global best is going to update. Earlier global best is a 35 but now remains in the 35 only. No more 35. What we have to do here this variable, third person variable is 121, but the best solution in the previous guy is a 35. Now we can keep that 35 remains. So we will not update the global best. So in this example for third person while you are calculating, is not updated the local best and global best, local or a personal best. Now for fourth one, we can see what is happening in the fourth solution. In a fourth solution, again, we are doing the velocity and position. The velocity is here, this value, and you are doing as a position by adding the um, previous one will get a new position. So new position is not out of bounds. So we can go for as a function value. So for that function value is a 28. Now what is the observation you can notice? Earlier fourth guy solution is 1 or 2, but now is getting as a 28. In this case, personal best will update and global best also will update. So the reason is the earlier value is not less than 28. So that will be as a 1 or 2. So now that's the reason now it is improved. It's got minimum function value is 28. So therefore, you consider the fourth person personal best is updated as a 28.13 and global best also this is a minimum when compared to the previous 30 or something. So for both earlier it was 35, now it is a 28.13. So therefore, what will happen you can notice the whenever the new solution is a better solution, then personal best will update 100%. And global best, whether it has to update or not, is that decided by the personal best solution. In personal best, if that's is a earlier will be minimum, and now it is a worst will not update. But similarly, global best also. That is the fourth type. Now, fifth one also, you repeat that problem, and you can again, it is not violating, then go for function value, and here you can see x5, yeah, violated. You can see here 11.87. So therefore, what you have to do, you have to keep this value is a 10 only because it is violated. So now you can make it to 10. This is the now x5 solution. Then we'll go for as a function. So function is now it become 234. So earlier it is only 113. That's why we'll not update the personal best. No update in personal best. And this is also worst when compared to the global best. So global best will never update. If the value is less than that only it will update. So in this solution 5, no update for global best as well as the what you call it as the local best. Now one set is over. So what we can observe here, we can complete first iteration random generation is this one. We randomly generated the population, you substitute in a function, we'll get it as a function value. In that first iteration, starting all these personals will be as a personal best, all this will be as a function best, and one new velocity or to calculate velocity vector to move with some velocity. There is it will get as a new position for that velocity is required. And from among this random, which one is minimum? 35 is minimum. Corresponding control variables are this that you can represent as a P best and G best. Then what you can do is we can perform this with a different iteration P best and G best, and finally we'll get as a new solution is this one at the end of the first iteration. After doing the velocity and position, then new solutions are this corresponding solution is 1.7 because it is not that they here you can see 28 is the minimum. That's why this will become as a global best. And of course, for that particular candidate, that may be personal best. But all other will compare with the previous value. Suppose you can see 80, but this guy is 159. So this only the personal best. And this is 140 and this is 64. This will be as a personal best. Like that, it will modify, yeah, and accordingly. So this is all about the first iteration. And then second iteration, what you have to do? You consider this is your base. So how we consider this is a base with some velocity. Same manner, instead of this, you can take this. Instead of this, you can take this. And for this. We can repeat the all these solutions again, velocity, calculate, and then position. After getting velocity, we can add previous position, we'll get it as a new position. So like that, second iteration. will going to be first step, second step, all the steps will repeat for the second iteration. And then we can update the variables as per the every iteration. You can see the control variables are within the limits or not. At the same time, we can see if anything is violated, then we can make it as a within the limits. So like that, we can repeat this and we'll get the answer. So here pseudocode for MATLAB programming, and this we can see as per the steps only, nothing different. You can see initialization. This is fixed one, lower bound, upper bound, number of populations, number of iterations, and some constants in the problem. W, C1, C2, all these things we have to fix it. Then randomly you need to generate. So you're getting as a random generation initially with random population and with velocity v and within the bounds, and evaluate the objective function value. Let it be as a p vector and assign the best value. So after generating this, in that which one is the minimum and which one is the maximum, we can keep that is a minimum function value, and that is a f p based, and the corresponding control variables are the uh, best values for the particular solution. So like that, what we can do is we have to assign, uh, we can assign the p best and function best values first. Then we can see the iteration, identify the solution with best fitness and global best. And that obviously individual bests are the first rows, and then among the all five population, who is the best, that will be the global best. Now we'll start the iteration. The first iteration, you can keep it as a 1 to t, and that is total number of iteration. Then internal side for first person. This is iteration. In how many populations are there? Five populations. So therefore, first population or a first person solution, two things we need to do. What we need to do, velocity we have to calculate, and then position we have to update. So while we are calculating the velocity, use this formula, and then position, then use this formula. And if these two are calculated, and go for as a updation, whether you want to go for update or not, that decided by the value. If that value is better, new solution is better than the old, then only we need to consider. Otherwise, we have to leave that solution. So updations will not happen. And like that, this again will come to the second person. And again it will come for third person until if fifth person also over, then one iteration is over. Then we'll go for upper for loop. That is t will become as a 2 and will repeat inside 5 times, and again it will go for upper. If it is a 5 population, like do this. This is the checking to go for as a updation. The new solution is in the better solution, then we'll go for update. Otherwise, we'll not. The same thing in the later point of time, we'll get it this acceleration coefficients C1, C2, I taken as a 1.5 or something. Why we ought to take 1.5? What will happen if it is 0? Particle move in the same direction until it has the such space boundary. If I keep is 0 and greater than 0 for C1 and is equal to 0 for C2, then in that case, particles are independent hill climbers, and particles perform the local search only. And otherwise case can see entire swarm become as one stochastic hill climber. All particles get attracted to the single point. So in that case, so now if both is equal, then you can see that particle is attracted towards the average best, that is a p best, and then g best. Whereas C1 and C2, C1 is greater than C2, particle attract towards the west, P best, and it is less than C2, then it is towards the G best. Low value of C1, C2, smooth particle trajectory, and high value of C1, C2, abrupt movements. So you should not take very high value or very low value. For that later point of time, we have as a calculation. If you want to go for MATLAB programming also, you can able to do this same logic, whatever the function you can take it, control parameters, whatever values we are taking, that also you can do. And then we have to calculate random population vector, then velocity vector, and you can update this using the best values, and we start the iteration new. Mean we are identifying the p best, g best, and all. After that iteration started, and inside loop is number of population. We are calculating the velocity and then position. And then we can modify your p best and boundary violation. If any variable is violated, we can back to the lower bound violation, make it to lower value, upper bound violation, make it to upper value. Like that, I have to do keep on this process. And finally, we can able to get the best solution. So this is the MATLAB code for the above problem. So we'll stop class today, and let's see the next class. If I have any doubt, you can ask me. And all of you must start uh, project, mini project. Then if you have doubt, you can unmute and ask me. Otherwise, you can leave.